Hello and welcome to this video about matter. Density is defined as the mass per unit volume, and this is a concept a lot of students struggle with. They find it hard to distinguish between mass and density. It might be good to start by asking them a trick question such as, which is heavier, a ton of feathers or a ton of lead? You can bet that most students will say a ton of lead. But hopefully some bright spark will point out that actually they have equal mass, 1 tonne. Then you can start to unpick what is different about a tonne of feathers and a tonne of lead. And hopefully you can explain to them that a tonne of lead would basically fit on a bench top, but a tonne of feathers would probably fill several science labs. You might like to describe the density of something as heaviness for its size. Something you can do is give the students blocks of different materials with the same volume to hold, and they should be able to feel that the mass of them is very different. For example, this cube of cork is a lot less heavy than this cube of iron, even though the volume is the same. A nice thing to do is to get a citrus fruit like this and put it in a trough of water, and the students should see that it floats. You can ask them what they think will happen once it's been peeled. Let's have a look. Right, let's see what happens now. Our orange is sunk. It's actually the peel that is less dense than water, and when the orange is still wrapped in the peel, then the overall density is less dense than water. But once we've peeled it, the orange itself is denser and will sink. When discussing the formula for density of mass per unit volume with students, it's really worth emphasising that the word per means for every. For example, this beaker of water here, the water has a density of 1 gram per centimetre cubed. That means there is 1 gram of mass for every 1 centimetre cubed of water. This piece of iron has a density of 8 grams per centimetre cubed. That means every centimetre cubed of the iron has a mass of 8 grams. Also with the formula, you can teach your students to love density. Mass over volume. Whilst the SI unit for density is kilograms per metre cubed, many students, especially the younger ones, will find it easier to think of density in terms of grams per centimetre cubed. You do have to be very careful though when converting between these units. Most students will be quite happy with the fact that there are 1,000 grams in a kilogram, but they might struggle to realise that there are actually 1,000,000 centimetres cubed in a metre cubed. You'll have to tell them that it's 100 centimetres times 100 centimetres times 100 centimetres to give them the million. And when we combine these two factors together, we end up with a density in kilograms per metre cubed 1,000 times that of the one in grams per metre cubed. So for example, water has a density of 1 gram per centimetre cubed, or 1,000 kilograms per metre cubed. Density is one of the GCSE required practicals, and students are required to find the density of regular shaped items, such as these blocks, and irregular shaped items as well. So we're going to start off by finding the density of this zinc block. So first of all, I'm going to use a balance to find the mass. And its mass to 2 significant figures is 53 grams. Then I need to find the volume by multiplying the length times the width times the height. So let's have a look. We have a length of 2.0 centimetres, a width of 2.0 centimetres, and surprise, surprise, a height of 2.0 centimetres. So to find the volume, I multiply these together, and that gives me 8.0 centimetres cubed. Now I need to find the density, is the mass divided by the volume 53 grams divided by 8 centimetres cubed to two significant figures, that is 6.6 grams per centimetre cubed. And if I convert that into kilograms per metre cubed, I need to multiply by 1,000 to give us 6,600 kilogram per metre cubed for my density of zinc. Now we're going to see how we can find the density of an irregular shaped object like this weight I've got here. So first of all, we find the mass in exactly the same way by putting it on the balance. And my mass to two significant figures is 69 grams. We can't easily find the volume with a ruler in this case, but let's see what happens when we put the mass into a cylinder of water. When I lower the weight into a measuring cylinder, we can see the volume of the liquid goes up. It's increased by the volume of the solid that I've put inside it. We don't get a very accurate reading though on this measuring cylinder because it's only calibrated to the nearest milliliter or centimetre cubed. So there's a better way of doing it. We need to use the displacement of water using a displacement can or Eureka can. Here I've got a couple of Eureka cans which are just a pot with a spout. And what we need to do is we need to fill them up to the very brim until the spout is just overflowing. I'm going to use this one for my mass because it's smaller. The mass fits in it quite nice and easily, but it's going to give me a more accurate reading than this large one. I'm going to stand it on a beaker here to give it a little bit more height so I can catch the water when it overflows. So I'm now going to fill it up. So it overflows. I'm waiting for it to stop dripping. Now we're ready. When I lower the mass in there, the water is going to overflow and the volume of water displaced is going to be equal to the volume of my object. I'm going to catch that water in a measuring cylinder. So I'm going to choose this small one because my mass is only quite small and I want to get the most accurate reading I can. So here goes. You need to lower it quite gently and carefully because you don't want to cause sort of ripples and overflowing. And I'm just going to hold it just under the surface until the dripping has stopped. So my measuring cylinder can now tell me the volume of the solid. That's 7.2 centimetres cubed. So now I can calculate the density as I did before. So now I have my mass, 69 grams, and my volume, 7.2 centimetres cubed, and I find my density, again, as mass divided by volume, 9.6 grams per centimetre cubed. And in kilograms per metre cubed, that is going to be 9,600 kilograms per metre cubed. And finally, in the required practicals, students also need to be able to work out the density of liquids. You could give them a mystery unknown solution like this one in which they need to find the density. So what we need to do is use a measuring cylinder to find the volume and again use our balance to find the mass. So let's see what the mass of the measuring cylinder is. And we'll press our tare button to bring it back down to 0. I'm now going to add 20 centimetres cubed of my mystery liquid to my measuring cylinder. There we go. And that is reading at 21.2 grams. So our mass is 21.2 grams and our volume was 20 centimetres cubed. So our density is going to be 21.2 grams divided by 20 centimetres cubed, which gives us 1.06 grams per centimetre cubed. Students could then compare that figure with some data in a lookup table to see if they can work out what their mystery substance is. So hopefully this video will give you some ideas about how to introduce and discuss the concept of density with your students, and also help prepare them to do the required practicals.